Hello everyone, welcome to the next lecture. In this lecture, we are going to learn about Kirchhoff's laws. Okay. So why do we study these laws? Okay. So these laws are studied in order to analyze various kinds of your electrical circuits. Okay. They are also used to find the value of, for example, voltages, current, resistances. Okay. And they are also used to solve various kinds of complex circuit equations. Okay, to solve various complex circuit equations. Okay, so the first law is your Kirchhoff's current law. Okay, also known as KCL. So this law basically states that the algebraic sum of currents entering a node is zero. Okay, so basically this particular law is based on law of conservation of charge. Okay, law of conservation of charge. Okay, so mathematically this law is given as summation of I is equal to 1 to n, I of n is equal to 0. Okay, so this is an important expression and you need to remember it. So where n stands for number of branches. Okay, so stands for number of branches connected to that, so connected to that particular node. Okay, connected to that particular reference node on which we are applying your KCL. Okay, so in order to simplify, in order to explain KCL, let's say we have a diagram. Let's say this is the reference node n. Okay, and 5 branches are connected. Each of the branch is carrying a specific value of current. Let's say this is I1. Okay, this is I1, this is your I2. Okay, this is I3, this one is your I4, and this is the I5. Okay, so what we can, so according to KCL, what we can say is I1, okay, I1 minus of I2 minus I3 plus I4 minus I5 will be equal to 0. Okay, so why negative sign is applied to I2, I3 and I5? The reason for that is because the current I2 is leaving the reference node n, whereas I1 and I4 are both entering this particular node. Okay, so the summation of these 5 currents will be equal to 0. Okay, another example we can take, like let's say these are the two resistors R1 and R2 over here, and these are the 3 current sources. Let's say this is your I1. Okay, this one is your I2. Okay, and this one is the I3. Okay, so and let's say this is the reference node on which we are applying the KCL. Okay, so according to KCL, what we can say is, I1 minus I2. Okay, so I1 minus I2 plus I3 will be equal to 0. So I hope it is clear like how we can apply KCL, okay, on a particular electrical circuit. Let's start with the second law. So the second law is your Kirchhoff's voltage law. Okay, so Kirchhoff's voltage law. So this law states that the algebraic sum of all the voltages around a closed loop is 0. Okay, so this particular law is based on law of conservation of your energy. Okay, so it is based on law of conservation of energy. Okay, so mathematically KVL is given as summation of I is equal to 1 to n, V of n is equal to 0. Okay, so this is also an important equation which you need to remember. And so where n is the branches, so the number of the branches which are connected, okay, connected to the reference loop. Okay, reference loop. Okay, so let us explain KVL. So let us explain KVL by the help of a electrical circuit. Okay, so let's say this is an electrical circuit over here, and let's say this is the voltage source, you can say V1. This is a voltage source V2, and this one is your V3. Okay, and these are the three resistors. Okay, so the voltage drop across it, let's say this is plus minus, this is V4. Okay, over here also V5. Okay, and the voltage drop, so the voltage drop across here is your V6. Let's say this is your reference loop. Okay, this is the reference loop over here. Okay, and the current is flowing in this particular circuit. Okay, so you need to understand one thing. While traveling through a loop, if there is a potential rise means the current is flowing from the negative terminal to towards the positive terminal. Then we will apply a positive sign. Okay, for potential rise, we will apply a positive sign. Okay, for a potential low, okay, so for a potential low, we will apply a negative sign. Okay, for example, in this case, if the current, as you can see, the current is moving from the positive sign towards the negative sign, so we will apply a negative sign over here. So there is a potential drop, or you can say a potential low. In the case of V2 also, we can see a similar case, that the current is moving from the positive terminal towards the negative terminal of the voltage source. Okay, so by applying KVL, what we can see is V1 minus V4 minus V2 minus V5 minus V3 minus V6 is equal to your 0. Okay, why negative sign is applied? Because as you can see, the current is moving from positive terminal towards the negative terminal, so there is a potential low, or you can say a potential drop. So that's why a negative sign is applied for the voltages 4, 2, 5, 3 and 6, and positive sign is given to V1 because the current is moving from the negative sign towards the positive sign. So I hope like these two laws are cleared. Okay, so we will apply these laws KVL and KCL further to solve various electrical problems. Okay, various kinds of complex circuit problems. So that's all for today, guys. I will see you in the next lecture. Thank you.